Hello there, Mr. Sutton bringing you the second of our lessons on inverse trig functions. In this one, we'll be figuring out values of compositions of a trig and inverse trig function.
For your warm-up, try this problem out. Find the exact value of tan of inverse tan of 6 over 17. You think you got it? So the trick here is a trig function undoes its inverse. Inverse tan of 6 over 17 is the angle whose slope is 6 over 17. If I take the tangent, if I'm finding the slope of the angle whose slope is 6 over 17, then I'm just going to get 6 over 17. Don't overanalyze it. Where it gets a little more interesting is when we're doing trig functions of different inverse trig functions. So in this situation, it's always a good idea whenever possible, if you have special values, take those first and then work your way out. So sine inverse, that's the right half of the unit circle. Radical 2 over 2, that's positive territory. We know that the inverse sine of radical 2 over 2 is going to be 45, because sine of 45 is root 2 over 2. So we've really just got tan of 45 degrees. And you could split this up into sine over cosine of 45. Since sine and cosine of 45 are the same number, you're really just going to get 1. For this next problem, things are getting a lot trickier. We'd love to find the inverse cosine of negative 1/5. However, 1/5, negative 1/5 is not a special value. So we actually need to use some other trickery here. One thing we do know, this angle inside here is the angle whose cosine is negative 1/5. So we can say cosine of this mystery angle here is negative 1/5. And then we just need to figure out what the cotan of that very same angle is. So this is actually a familiar situation. You might remember a few lessons ago we gave you one trig function and wanted you to find the other 5. This is just like finding the other 5 trig functions, only this time we're not telling you what quadrant you're in. You're going to need to figure out the quadrant using those inverse trig ranges. For this one, we know that inverse cosine only applies in quadrants 1 and 2. Since cosine is negative, that means we must be in quadrant 2. Now we already know that x values are negative because the cosine is negative, but knowing it's in quadrant 2 will also help us figure out the sign of the y value later on in this problem. So let's figure out, we always need x, y, and r to find the other 5 trig functions. We already know x. Since cosine is x over r, we know that x is going to be negative 1. We know that r is always positive, so r has to be positive 5, not negative 5. And to find y, we need our Pythagorean theorem, x squared plus y squared equals r squared. Since we're looking for y, we need the square root then of r squared minus x squared. So that's going to be the square root of 25 minus 1, square root of 24, which we could simplify to 2 radical 6. Now hold on just a sec before we do that. Is this going to be positive or negative? Remember, we always have to ask x or y if it's positive or negative. You're in quadrant 2. Y is positive in quadrant 2. So this will be a positive 2 root 6. And we didn't really need to write this little plus up here. I just wanted to emphasize that we are choosing positive. Negative could have been another alternative in a different question. All right. Cotan, remember, is x over y. We know the x value is negative 1. Here's our y value of 2 radical 6. And to simplify this radical, we just need to multiply by radical 6 over itself. So that'll give us negative radical 6 on top, negative 1 radical 6. On the bottom, we've got 2 times just plain old 6, so that's 12. And that's going to be our final answer. Here's another problem like that where we don't necessarily know the special trig value of this. So pause the video, try this one on your own. All right, so we know that the tan of our angle is negative radical 3 over 3. Since inverse tan is only used in the right half of the unit circle, quadrants 1 and 4, we have to choose between quadrants 1 and 4. Our slope is negative. That means we must be in quadrant 4. That will be immensely useful in figuring out the x and the y values. We know that since we have y over x is normally what tangent is, we know that since this is a negative fraction, one of those values must be negative. In quadrant 4, we know that x is positive and y is negative. So we're going to have a value for x of positive 3, because x is positive in quadrant 4, and then this negative is going to have to go with the y value, so negative radical 3 will be our y value. We still need the r value, though, to get cosecant, because you might remember that's r over y, the reciprocal of sine. So to find that, we'll use Pythagorean theorem. We have 3 squared plus radical 3 squared. That's going to be 9 plus 3, square root of 12. And the radius is always positive. And 12 we can simplify to 2 root 3, because you can split 12 up into radical 4 times radical 3. All right, very good. Now, cosecant, that's r over y. Here's your radius, already simplified. So that's 2 radical 3 on top. Y is negative radical 3, so that's going to go on the bottom. And we can actually cancel out those radical 3s, so it's nice that we reduced this already. So that'll just be negative 2 when the dust settles. So this concludes what was probably the most complicated lesson in our chapter of simple trigonometry. In the next chapter, we'll tackle some even more advanced trigonometric concepts. Until next time, this is Mr. Sutton signing off.